Have you ever really stopped to think about how much artificial intelligence is, well, just around us every day?
It's pretty much everywhere, isn't it?
Yeah, like from unlocking your phone, the shows your streaming service queues up, even how your email filters out spam. AI is working behind the scenes.
Absolutely, silently humming along.
But even though it's so common, there's still so much buzz and honestly, maybe some confusion about what AI really is.
A lot of hype, definitely. And some misunderstandings, too.
So today, we wanted to do a deep dive into artificial intelligence, try to cut through that noise, get to what you really need to understand.
Sounds good.
We've gathered quite a bit of material for this. We looked at an AI glossary for staff and students, the Artificial Intelligence for Dummies book,
Yeah.
the big Wikipedia entry on AI,
Right, that's a useful one.
the Fundamentals of Artificial Intelligence module, and even, this was interesting, a Reddit thread about how people actually learn AI.
Oh yeah, practical experience. Good mix.
Yeah.
So our goal here really is to give you a clear, solid understanding. No jargon, if we can help it.
Exactly.
We want to get past the buzzwords, show you what's real, what's maybe overblown, and hopefully offer some surprising bits along the way. Separate the hype from what's actually happening.
Okay, let's dive in then. When we talk about AI being everywhere, what are we actually talking about? What's the core definition?
Well, at its most basic, artificial intelligence, AI, it's the ability of machines, computer systems, to do tasks that normally require human intelligence.
Like what kind of tasks?
Things like recognizing speech, like your smart speaker, making decisions, solving problems, even learning from experience. John McCarthy, who's often called the father of AI, put it pretty neatly.
How did he define it?
He called it the science and engineering of making intelligent machines, especially intelligent computer programs. Simple as that, really.
Okay, but that word intelligent, that feels like the tricky part. What does intelligence mean for a machine? How's it different from, well, our intelligence?
That's a really, really important question. And honestly, it's where a lot of confusion starts. Human intelligence is incredibly complex, right? It involves learning, reasoning, understanding complex ideas, seeing connections, finding meaning.
Right, much more than just processing data.
Exactly. Now, computers, AI, they can mimic the process. They can be given a goal, gather info, crunch the data, figure out if they succeeded. But, and this is key, they don't understand in the human sense.
Because it's all just math underneath.
Precisely. It's all based on mechanical, mathematical procedures. What's fascinating, though, is looking at the types of human intelligence AI can simulate.
Oh, interesting. Like what?
Well, think about different intelligences. AI can actually be pretty good at what's called bodily kinesthetic intelligence. Think robots on an assembly line doing precise, repetitive movements.
Okay, yeah, I can see that.
But then you have things like creative intelligence or interpersonal intelligence, understanding yourself, having self-awareness, desires, that's still uniquely human. Machines just don't have that inner life. They don't want anything.
Right, so, okay, if they lack that true understanding, how do they actually do these intelligent things? What makes them work? What are the building blocks?
It really starts with algorithms. Think of an algorithm like a recipe, a really detailed step-by-step set of instructions that tells a computer exactly what to do to solve a problem or finish a task.
So like the basic instructions.
Exactly. In AI, algorithms are used for everything. Processing data, making decisions, predicting outcomes. They're the fundamental logic.
Okay, but recipes don't usually get smarter on their own. This is where it gets really interesting for me. How do these algorithms go from just following instructions to actually learning and adapting?
Now you're getting to the core of modern AI. That's where machine learning, or ML, comes in. If algorithms are the recipes, ML is like the computer learning to cook better over time by tasting the results.
Okay, learning from data.
Precisely. It's a branch of AI where computers learn from data and improve their performance without being explicitly programmed for every single possibility.
Then there's deep learning, right? I hear that term all the time.
Yes, deep learning is a specific type of machine learning. It uses layers upon layers of artificial neurons. Think of them as interconnected processing units to spot really complex patterns in massive amounts of data.
So more layers, more data means it gets better.
Essentially, yes. The deep refers to the depth of these layers. It's particularly good for tasks like recognizing subtle differences in images or understanding the nuances of spoken language, things that were incredibly hard before deep learning.
You mentioned neurons. That sounds very biological, very brain-like. Is that connection real or just a convenient term? Are these machines thinking like us?
It's more of an inspiration than a direct copy. Neural networks are the AI models that are structured a bit like the network of neurons in our brains.
Mhm.
They have layers of these interconnected nodes or neurons that process information. When you get networks with two or more hidden layers between the input and output,
Oh.
those are called deep neural networks.
Hence deep learning.
Exactly. They're designed to learn complex relationships and find patterns in data, much like our brains learn to recognize faces or understand language. But crucially, without the consciousness or subjective experience.
It's still amazing how this structure allows AI to blend so smoothly into our daily lives. Sometimes we don't even notice it's there. How does that work practically, like when we talk to our phones or use translation apps?
A massive piece of that puzzle is natural language processing, or NLP. That's the AI field focused on enabling machines to understand, interpret, and respond to human language, written or spoken.
So NLP is how my phone understands me.
Largely, yes. And a key part of that for spoken language is automated speech recognition, ASR. That's the tech converting your voice into text so the NLP system can then process it. And building on that, you get chatbots and conversational AI. Chatbots are basically programs designed to simulate human conversation, usually through text or voice.
Right, like customer service bots.
Yeah, that's a common use. Conversational AI is a bit broader. It refers to technologies like chatbots or virtual assistants that you can actually talk to, and they provide information or help in real time.
So things like ChatGPT or maybe Microsoft Copilot, those fit in here.
Absolutely. Prime examples. ChatGPT from OpenAI is a powerhouse in understanding prompts and generating incredibly human-like text for all sorts of tasks.
Yes, impressive.
And then Microsoft Copilot or GitHub Copilot are AI assistants built into other software, helping with things like summarizing documents, drafting emails, or even writing computer code.
Okay, so it's not just text and speech.
Not at all. We're seeing more multimodal AI. This is AI that can handle and integrate different types of data simultaneously, text, images, audio, to build a richer understanding.
Like understanding a video with both image and sound.
Exactly. And speaking of audio, there's voice cloning technology. This stuff can analyze someone's voice and then generate completely new speech that sounds just like them.
Wow, that's potentially useful, but also maybe a bit concerning.
It definitely raises interesting questions, which we should probably touch on later.
Okay, so we've covered language, text, sound. What about sight? How does AI process visual information like photos or videos?
That falls under computer vision. It's the field of AI that lets computers see and interpret visual information from the world. Images, videos,
What kind of tasks?
things like recognizing objects in a photo, analyzing medical scans like X-rays, facial detection.
Yeah.
It's already being used quite a bit in healthcare and for things like self-driving car technology.
And what if there's text in an image, like a scanned document?
That's optical character recognition, or OCR. It's technology that specifically converts images containing text typed, handwritten, or printed into machine-readable text data. Makes scanned documents searchable and editable.
Got it. So all of this understanding language, seeing images, learning, sounds like it needs a huge amount of fuel. Where does all the information come from? Data must be critical.
Absolutely foundational. You can't have modern AI without data. Lots and lots of data. We're talking big data.
Okay, define big data, just
Yeah.
really big.
It's more than just size, though size is part of it. Big data refers to extremely large, complex data sets coming from all sorts of places. Social media, sensors, website clicks, financial transactions.
Data that's too messy for old school databases.
Exactly. It's often unstructured or semi-structured, and it comes in so fast and varied that traditional processing methods just can't handle it.
Huh.
But it's precisely this kind of massive, messy data that AI models, especially deep learning, thrive on. It's the raw material for learning patterns.
So the breakthrough wasn't just the algorithms, but having the data to feed them.
That's a huge part of the story, yes. Deep learning ideas existed for a while, but it was the arrival of big data and powerful enough computers that really made them take off.
Okay, so you have this mountain of data. How do you find the useful stuff in it?
That's data mining. It's the process of sifting through these large data sets to discover hidden patterns, trends, correlations, useful insights you wouldn't see otherwise.
And I saw a term, data augmentation. What's that?
Right. Data augmentation. Sometimes, even with big data, you might not have enough variety for certain tasks. Data augmentation is a technique to artificially increase the diversity of your training data.
How? Like making copies?
Sort of, but smarter. For images, you might rotate them, change the brightness, crop them slightly. For text, you might substitute synonyms. It helps the AI model become more robust and generalize better to new, unseen data.
Okay, this makes sense. But dealing with these enormous data sets, mining them, running these complex AI models, it sounds like you'd need unbelievable computing power. How is that managed?
You're spot on. And that's where cloud computing is absolutely essential. Instead of needing your own supercomputers locally, cloud computing uses a network of remote servers, accessed over the internet, to store, manage, and process data.
So you're essentially renting computing power and storage.
Pretty much, yeah. It makes massive computing resources accessible and scalable. Microsoft Azure is a major player here. It's a cloud platform offering tons of services, including data storage, analytics, and ready-to-use AI tools.
And you mentioned services. There are different types.
Right. Typically, cloud services fall into categories like infrastructure as a service, IS, which is like renting the basic hardware, platform as a service, KS, which gives you tools to build and deploy applications, and software as a service, SaaS, which is basically software you access online, like webmail.
Okay. And how do developers actually use the AI capabilities in the cloud, like adding speech recognition to their app?
That's often done using APIs, application program interfaces. Think of an API as a standardized messenger or translator
Yeah.
between different software systems.
So it lets different programs talk to each other easily.
Exactly. Cloud platforms like Azure offer cognitive services APIs for things like computer vision, speech services, language understanding, LUIS. Developers can just plug these APIs into their applications to add sophisticated AI features without having to build the core AI models themselves.
That must really speed things up.
Immensely. It democratizes access to powerful AI capabilities.
And for people just starting out, maybe researchers or students, where do they get the initial data to train models if they don't have big data resources?
That's where public datasets come in handy. There are many large datasets made available to the public specifically for research and data science projects.
Like what?
Things like image collections for computer vision tasks, text corpora for NLP, even specific datasets like Azure's open datasets, which might include things like public weather forecasts or economic data.
Useful. But I imagine you need to be careful with public data.
Absolutely. Yeah. You always need to evaluate the quality. How was it collected? Is it representative? And critically, be aware of potential biases within the data or privacy implications, especially if it involves information about people. Responsible use is key.
Okay, we've covered a lot of the how. Let's pivot to the what's. How is all this AI tech actually impacting our world? You mentioned it's everywhere, but let's get specific.
Right. Beyond the phone examples, think about your home. Smart thermostats that learn your heating preferences, maybe smart lighting or security systems. Even your email's spam filter is constantly learning. Smartphone reminders that pop up based on location or time. It's deeply integrated.
And looking at the bigger picture, entire industries are changing, right?
Definitely. Take healthcare. AI is being used to analyze medical images like X-rays or MRIs, often spotting things faster or more accurately than humans. It helps with treatment planning, managing chronic diseases proactively.
What about things like robot surgeons?
Yes. AI-supported robotics are used in complex surgeries for greater precision. And it's not just about diagnosis and treatment. AI powers tools that analyze vast healthcare data to predict disease outbreaks or patient risk factors, even helping elderly care with conversational AI companions.
Wow. Okay, healthcare is huge. What else?
Agriculture is another big one. AI is helping tackle global food security challenges. You've got agricultural robots for tasks like harvesting. Computer vision monitors crop health and soil conditions over vast fields.
Using drones or satellites.
Often, yes. And predictive analytics can forecast weather impacts, disease outbreaks, or pest infestations. Microsoft even has an AI sowing app that advises farmers in India on the best time to plant based on weather patterns and other data sent via text message.
That's incredibly practical. What about shopping? Retail must be using AI heavily.
Oh, absolutely. Retail uses AI for everything from optimizing supply chains and forecasting demand for products to understanding customer behavior, personalizing marketing, and setting dynamic pricing.
Like when prices change online based on demand.
That's often AI at work. Plus, you see chatbots for customer service, self-service checkouts. AI systems analyze sales data to predict what promotions or store layouts might increase sales. It's fundamentally changing how businesses operate and interact with you.
It sounds incredibly powerful and mostly beneficial, but we know it's not all smooth sailing. There are definite complexities, ethical concerns, potential downsides people talk about.
You're absolutely right to bring that up. It's crucial. One common issue, maybe more philosophical, but with real effects, is anthropomorphism.
Giving human qualities to machines.
Exactly. We tend to project human-like consciousness, feelings, or intentions onto AI, especially conversational AI. This leads to unrealistic expectations. Maybe thinking a chatbot actually feels or understands like a person when it's just sophisticated pattern matching.
Which could be misleading.
Very much so. Then there were more direct problems like AI distortions. These are errors, biases, or just plain inaccuracies in AI systems,
Where do those come from?
often from the data used to train them. If the data reflects existing societal biases, the AI will learn and potentially amplify those biases. Or sometimes the algorithm itself is flawed, or it optimizes for the wrong thing.
Do you have examples of where this has gone wrong? Real-world cases?
Sadly, yes. There was a well-known case where Google Photos mislabeled images of black people as gorillas. The root cause was likely that the training data didn't have enough representative images.
Wow, that's bad.
Really bad. Another example, maybe less obvious but equally concerning, involved a healthcare AI. It classified patients with asthma as having a lower risk of dying from pneumonia.
That sounds completely wrong. Asthma is a risk factor.
Exactly. But because asthma patients typically get more intensive care because of their condition, they statistically had better outcomes in the data set the AI learned from. The AI found a correlation but missed the crucial context, leading to a dangerous conclusion.
That really highlights the problem of just trusting the output without understanding why, doesn't it?
Precisely. And that brings up the challenge of explainable AI, or XAI. For many complex AI models, especially deep learning, it's incredibly difficult to trace back exactly why it made a specific decision. It's like a black box.
Which is a huge problem if the decisions have serious consequences.
A massive problem. We need ways to understand and audit AI reasoning, especially in high-stakes areas like medicine, finance, or justice.
And related to bias and trust, what about misinformation? That seems like a growing concern with generative AI.
A huge concern. Even before generative AI, recommender systems on social media, designed purely to maximize engagement, sometimes led users down rabbit holes of extreme content or conspiracy theories by creating filter bubbles.
Right, showing you more of what keeps you clicking.
Exactly. Now add deepfakes, incredibly realistic AI-generated images, audio, video. The potential for creating convincing fake news, propaganda, or personal attacks at scale is terrifying. AI pioneer Geoffrey Hinton specifically warned about this enabling manipulation.
Spreading false information that looks completely real.
Yes, and alongside that you have major privacy issues. AI systems, by their nature, often require vast amounts of data, including potentially sensitive user data browsing habits, location, personal communications.
So there's a tension there between needing data for good AI and protecting privacy.
A constant tension. Developers are working on techniques like aggregating data, removing personal identifiers, de-identification, but it's an ongoing ethical and technical challenge to balance innovation with fundamental rights.
Okay, so there's a lot to be aware of, both good and bad. For listeners who followed along and want to maybe learn more, dig deeper themselves, where should they go?
Well, if you're interested in the technical side, Professor Andrew Ng's courses on platforms like Coursera are legendary. He covers machine learning, neural networks, deep learning very clearly.
Okay, Andrew Ng.
And he's recently added courses specifically on LLM's large language models, the tech behind things like ChatGPT. These get into really current concepts like prompt engineering.
Which is like writing good instructions for the AI.
Basically, yeah. Crafting effective prompts to get the output you want. Also, retrieval augmented generation, or RG, which is a technique combining the LLM's knowledge with real-time information retrieval, like searching the web, for more accurate answers.
Making it less likely to make stuff up.
Hopefully. And fine-tuning, which is about taking a general pre-trained AI model and specializing it for a specific task using smaller, targeted data sets.
Interesting. So there are structured ways to learn this stuff. What about coding, if someone wants to actually build AI applications?
The dominant language by far is Python. It's relatively easy to learn, has simple syntax that reads a bit like English, and crucially, has massive libraries, collections of pre-written code specifically for AI and data science. Makes development much faster.
So Python is the place to start.
For most people getting into AI development, yes. Our programming is also very popular, especially for statistical analysis and data visualization within AI projects.
Okay, good pointers. Wow, we've really covered a lot of ground today trying to decode AI.
We have, from the basic definition
Yeah, what AI is, the building blocks like algorithms, machine learning, neural
to
networks.
how it actually works in the world
Mm.
through NLP and computer vision, fueled by big data and the cloud.
Right, and then seeing its impact everywhere, healthcare, farming, how we shop.
And importantly, facing those challenges,
Mm.
the biases, the explainability problem, misinformation, privacy.
It's definitely a technology that's not just coming, it's here, and it's reshaping things fast. Getting a clear understanding feels more important than ever.
It really does. And perhaps that leaves us with a final thought, something for you, the listener, to mull over.
Yeah.
As AI gets woven ever deeper into the fabric of our lives, how do we make sure that human intelligence, our creativity, our self-awareness, our capacity for genuine understanding and empathy, how do we ensure that guides AI's development? How do we use AI responsibly, preventing those distortions and manipulations we talked about?
That's a big question. What role will each of us play?
Yes, exactly. In a world increasingly filled with AI-generated content and decisions, how will you learn to tell the difference between algorithmic output and human truth? How will you help shape how this incredibly powerful technology serves humanity best? Something to think about.